So up here,
How come you're not doing like sort of a hidden line? Because if you look at it from the top, or should you only see?
right, so here's my top, right?
I guess
So the top, this is all visible edges that I could see.
yeah.
From the bottom, it would be hidden, right?
Wait, from the top, Joanne,
Yeah,
if you're looking straight down on top of that, you wouldn't be able to see a difference in the depth of
so
that.
looking straight down on here, all these edges are visible lines. All these edges that I'm seeing are visible lines from the top.
I feel like if you're really looking straight on it, it would look, and if there's no discoloration of the edges, it would look like one flat.
Yeah, okay, I see what you're saying. So you're saying that when I look down, I do have to do an engineering drawing?
Yeah.
Even though it looks like one solid plane and you can't see the depth, you have to denote the edges that you can see.
It's like the front view, kind of you see the L.
Yeah, so the front view,
Yeah.
you see how you see the L? The opposite L? Backwards L, right? So you see the L, but you also see this piece. But it's all looks like it's on one plane. And from the top, it's the same thing. You see the T first, but then you see these below. So each one of these drawings is not determining, you're not showing where the depth is. It's these three together that give you the depth. So again, look up here. If you're only given, let's try to improve our 3D visualization. Look at the three drawings right now that I have up there. First, what's the name of each one of them called? Orthographic, right? Each of these are orthographic. The front one is the front, the top one's the horizontal, the one on the right is the profile. When I look at all these three, I can tell that from the front, I see an L, so there must be an L on the part in the front. When I look at the top, I know that there is a T on the top because I see the edge. And then when I look at the right side, I know that from the right side, it's just a blank side, and this upside down T is shown on the left side in the back. It takes practice, right? It's like those, remember those 3D drawings where you look at it and your eyes have to cross and then you finally see it in 3D? It's similar to that. When you look at these three orthographic drawings, you have to kind of twist your mind to figure out how it looks in 3D. That's why in engineering drawings, not only do you get the three views, but you also get the three-dimensional drawing. These are important. If you could understand a three-dimensional drawing, why are there orthographics at all? It's because dimensioning. You got to dimension and you can only dimension sides. So this drawing right here is transferring to here. Let me,
We can see what we got on the test we did.
yeah, at the end of the year.
At the end of the-
Yeah. I'll show you what you got now and what you get at the end. Would you mind looking up again? So here's the front view, the right side, the profile, and the back, and that all, the dimension that it all has in common is height. So I'm drawing the height all the way out. And what is this line called that I'm using? This is called a construction line. It's a line that's very, very light, and if I were to photocopy this page, it wouldn't come out, it wouldn't copy. It's a construction line because it's used to construct stuff. And I want you all to help each other too, so as you're doing this, if you're already finished, look on with the person next to you, and just see if you could help.
How's the front view one?
Yeah, so let me cut something off.